Hi! In this video, I'm going to show how to use the VESC to control the motor with a pulse encoder, which can be useful for position control in robotics applications. So I'm going to use an outrunner with an AMT 102 encoder. You can buy this one on Mouser, for example, for 20 euros. This one. And in order to connect it, you can use the Hall sensor encoder port on the VESC, this one. So in order to do that, you have to remove the filter for the Hall sensors in case it has the filter. So for doing that, you have to remove R11 to R13, C5 to C7, and replace R8 to R10 with 0 ohm resistors. This way we'll get a straight connection from the inputs to the MCU pins. And a photo of that looks something like the following. You can see that you only have 3 resistors here. Those are 4.7 ohms, but you can use any value that is low enough. This happened to be what I had handy at the moment when I soldered them. So the next thing you have to do is you have to use firmware with encoder support. And this is a 4.10 hardware VESC. Let's see, wrong directory. So go to firmwares, hardware 4.10, and VESC encoder.bin, connect, and upload. So while it's uploading, we can connect the motor. And the encoder. Make sure that everything is connected. And go to BLDC tool, connect, and read the configuration. And this is the default configuration. So first we have to set the motor type to FOC, and I'm also going to decrease the current limits a bit, since I'm using a lab power supply and I'm going to hold the motor in my hand, and it should be a bit safer to hold it in my hand if I have less current. So I'm going to use 20 amps phase current limit, write configuration. And next, we have to go to the Advanced tab and set how many counts the encoder has. This one happens to have 2048 pulses per revolution, and each pulse will generate 4 counts. So use this value times 4, which is 8192, which is default in this case. Write configuration, and then I go to the FOC tab, and then we're going to hold the motor and click measure encoder. This will measure the offset ratio and whether the encoder is inverted. The offset is the offset between the electrical and mechanical position. The ratio, for example, if you have a 20 pole motor, the ratio will be 10. And inverted is whether the encoder is inverted. So for example, if you switch the motor phases, the motor will change direction, and then the encoder might or might not be inverted. So we got the results. We get an offset of 231 degrees and a ratio of 11, which is wrong because I know that it should be 10. So we try to measure it again. It works most of the time. Also, you can try to increase the current, then it will use a bit more force to run the motor in open loop. It runs the motor in open loop, by the way, using current control to figure out the offset and ratio. Most of the time it works even on 10 amps for this motor, for example, but how much current you use depends on the motor you're using. So let's see, this time we got offset of 206 degrees and a ratio of 10, and it's not inverted, and this seems plausible, so click apply. Next we measure resistance and inductance. We can use them to calculate the parameters for the current control loop, but the default parameter should also work. So, since we're going to use position control, we can decrease the time constant a bit to make the current control loop faster. Then we can also, make the position control loop a bit faster. Calculate KI, apply. And next is to set sensor mode to encoder. Write configuration. Now we should be able to run the motor in central FOC using pulse encoder, and it seems to work. Nice. So let's try position control. Let's set the position to 50 degrees and hit position. And now the motor tries to hold this position. You can see in the real-time data that when I try to move it, it will get some current. And when I move it too much, then the current limit will hit, which is 20 amps in this case. So we can also go to the Advanced tab and adjust the position controller parameters. This is the default one. Let's increase the KP value a bit from 0.3 to 0.5. Right. And try again. Now you can see that we have a bit more gain, so when I make smaller movements it will give more current. We also have the rotor position tab, and I have updated this one a bit. So you can, for example, you can plot the encoder position, and when you set a new goal value, for example 120 degrees, you can see that the encoder will jump to that position. You can also plot the position error. So now it's around 0 degrees. And if we go from 120 to say 300, you can see that we get an error, and we go back to 0. And it also had quite high current. You could also hear my lab power supply clicking. So if we go to real-time data and go back to, let's say, 20, you can see that we'll get a current pulse. So what we also can do, what I'm also going to do in this demo, is that I have another VEC, see this one, and it has a pulse encoder hooked up without the motor, just a pulse encoder, and I have modified the firmware so that it will just read the pulse encoder and send position control commands over CAN bus. So I'm going to hold this motor and connect the CAN bus to this one, and it should start up. And now let's put the pulse encoder here so you can see it at the same time. You can see that when I move it, the motor tries to follow this position. This jump was probably when this one found the index pulse. Also regarding the index pulse, when you first boot up the VEC and the index pulse isn't found on the encoder, then it will use open loop control and move the motor with this open loop RPM until it finds the index pulse, and as soon as it finds the index pulse it will go to closed loop control again. So let's go back to this tab, and you can see that, let's see, is this the error or the position? Yeah, this is the error. So you can see that when I move it, I will get some error, and once I release it, the error will go approach 0. You can also, for example, we can put a pen on this one with a piece of tape that I have prepared. You can see that when I move it, they should have a similar position. Yeah. Like the demo, this is like the demo that I had with the DC motor before. And it also still works for DC motors. So, yeah. This is the VEC running position control with a pulse encoder.